Hey there! In this section, we're gonna go deep into some inner workings of React once again. So we'll analyze renders in practical terms using this demo application and learn how to optimize wasted renders and performance in general using some more advanced React tools. This way, you'll be able to understand React apps even better and make them as fast and snappy as possible. We'll also go even deeper into the use effect hook because there's still a few more things that we need to learn. So this is another truly advanced section and one that I'm really excited to share with you. So get ready to take a lot of notes and really take your React skills and understanding to the next level one more time. We're gonna start this section by getting a quick overview of what can actually be optimized in React applications and how we can do it. So there are three main areas that we can focus on when we need to optimize performance of React apps. First, we can try to prevent wasted renders. Second, we can improve the overall app speed and responsiveness to make sure that the app is 100% fluid and without delays. And third, we can reduce the bundle size. So let's quickly look at some built-in React tools for each of these areas. So in order to prevent wasted renders, we can memoize components with memo, or we can memoize objects and functions with useMemo and useCallback hooks. And of course, you don't know what any of this means at this point, but we'll get to it over the next few lectures. We can also use a technique where we pass elements into other elements as children or as a normal prop in order to prevent them from being re-rendered. Now, to improve the perceived app speed, we can again use the useMemo and useCallback hooks, and we can also use the modern useTransition hook. And again, more about these later. Finally, we can reduce the bundle size simply by using fewer third-party packages in our code base, and we can also implement code splitting and lazy loading. Now, there is no need to use all these tools and techniques all the time. So the main goal of this section is to basically just give you access to these tools so that you can have them in your toolbox whenever a situation calls for one of them. And throughout this section, you will learn exactly when that is. So in which situations you need each of these tools. Also, keep in mind that this list of tools and techniques is by no means exhaustive. So there are many other optimization best practices that I already told you about before and that you are already using. For example, not defining components inside other components. And so I didn't include all of these in this list. So these are mainly tools that we will talk about in this or in future sections. Now, the first part of this section is going to be about optimizing wasted renders. However, to understand what wasted renders actually are, we first need to review when exactly a component instance gets re-rendered. So this will serve as a nice reminder of how rendering works in practice. So in React, a component instance only gets re-rendered in three different situations. First, when the component state changes. Second, a component instance gets re-rendered whenever there's a change in a context that the component is subscribed to. And this is exactly what we've learned in the previous section. And finally, as we learned in the section on how React works behind the scenes, whenever a component re-renders, all its child components will automatically be re-rendered as well. And so the third reason for a component to re-render is a parent component re-rendering. But now you might be wondering, what about prop changes? Doesn't updating props also re-render a component? Well, actually, that's technically not the case. So that's a common misconception, And actually, even I told you this at the beginning of the course, but it was only because you didn't know yet how rendering works. Because it is true that it does look as if components re-render when their props change. But what actually happens is that props only change when the parent re-renders. But when the parent re-renders, the children who receives the prop will re-render anyway. And so the real reason why a component re-renders when props change is that the parent has re-rendered. Okay, but anyway, it's important to also remember that rendering a component does not mean that the DOM actually gets updated, right? So all that rendering means is that the component function gets called and that React will create a new virtual DOM and do all the diffing and reconciliation that we have already talked about before. And this can be an expensive and wasteful operation, which brings us to an important topic of this video: wasted renders. So a wasted render is basically a render that didn't produce any change in the DOM. So it's a waste because all the diffing calculations still had to be done, but it didn't result in any new DOM. And so therefore, all the calculations were for nothing. Now, most of the time, this is actually no problem at all, because React is very fast. However, it can become a problem when re-renders happen way too frequently, or when the component is very slow in rendering. And so this can then make the application feel laggy and unresponsive. For example, not updating the UI fast enough after the user performs a certain action. So we want to avoid situations like that at all costs. So that's basically what we're going to be dealing with in the next couple of videos. We have used the React developer tools all the time throughout this course, but actually we have only used half of them until now. And so let's now meet the other half, which is the profiler. So for the first half of this section, let's actually bring back our atomic block project. So let's open that up in VS Code. And so I'm here in the app.js file, so the latest file that we wrote. So let's close that and let's npm start it. Okay, there it is. And so let's actually make this window a bit bigger so that we can actually see our developer tools. So, as I mentioned in the beginning, we have used the components React developer tool a lot, but we have never used the other part. So this profiler right here. So with the profiler, we can basically analyze renders and re-renders. So we can see which components have rendered, see why they rendered, and also how long each render took. Now in practice, we use the profiler by clicking here on this record button, and then we update some state. But before we go do that, let's change the settings here, and coming to this last tab, which says profiler, and then here we want to activate the setting which says that it should record why each component rendered while it was profiling. And so basically this will give us one of the three reasons that we talked about in the previous lecture of why each component has re-rendered. So whether it was a state update, a context update, or a parent re-rendering. All right. Now, if you reload the page, then you will have to reset that setting actually, which is a bit annoying. But anyway, now I will start recording and then I will update the state of the page by typing in here. So let's type 3 times so we see how that actually looks like in the profiler. And then we click there to stop the recording. And then here is our flame graph. So we can see the result in the flame graph and here in this ranked graph. So starting with the flame graph, this is basically just another way of representing the component tree. So as the parent, we have app, then we have our provider, and inside the provider we have indeed the header and the main, which in turn contain all of these components. So just like we have here. Now what's special about this is that some components are actually colored and some are gray. So the gray components are the ones that did actually not render while the application re-rendered. So main, posts, and app did not re-render, but all these others did. And the more yellow the color is, the longer it took to re-render. So the post provider, we can see, took the longest. Now in order to rank them, we can, as the name says, use the ranked tab here. And so here we can then very clearly see, for example, that some of these components were really fast to render, while this one here took a bit longer. And even though that's less than a millisecond, which is really nothing. Now, thanks to the setting that we activated in the beginning, we can also see why each of the components re-rendered. So here, for example, we can see that the post provider re-rendered because hook 2 changed. And so the hook 2 is simply the useState hook, which is storing this search query here. So then here, the provider usually doesn't say. And then here, the header re-rendered because context changed. So let's check that out actually here. So indeed, the header is consuming the context, and so therefore it changed as we updated the state here in the context, right? And the results and this form and the list, all of them are consuming the context. And so therefore, they then also updated as the component was updated, while the main and the post components are not consuming the context, and so they did not re-render. So this is how we can basically analyze this flame graph. Now up here, we have the different commits, how they are called. Or in other words, each of them here is one re-render. So I think that's easier to understand. And so since we did 3 times the same thing here, we should expect them to look basically the same. Now the timings have changed here for some reason, but the components that have actually rendered and not rendered are exactly the same. All right, and now let's try something else. So for that we can clear and then record again. And now let's simply click here on this fake dark mode button. So just one re-render. And so then here we only get this one column. And so this time, as we can see here, every single component has re-rendered, which makes sense because the state update actually happened right here in the main parent component. So here in the app component. That's why here it says that hook number 1 changed, which is this one. And then we can see here, for example, this one did render because the context changes or changed, which actually seems a bit strange, but we will come back to this later. So we will understand why React is saying this. So all the components that are consuming the state actually are telling us that they have re-rendered because the context has changed. While these two, which before were gray, are now also colored, and these two did re-render because the parent component rendered. And so again, when the parent component of the application, so the component at the top of the component tree, re-renders, then all the child components will re-render as well. Okay, let's just put this back, let's delete, and let's try another one. So 1, 2, 3, and 4. So let's see. And indeed, here we have our 4 state updates, or 4 re-renders. So in the first 3, we can see that only the form at post re-rendered. And so that is, let's see where that is. So that is because these are local pieces of state. And also this component has no child components. And so then only this one re-rendered the 3 times that we wrote something there. But then here we have a similar picture to what we had before. So not all the components have re-rendered here, like the footer and the main component did not re-render as a result of adding a new post. Okay, So feel free to play around with this new tool here as much as you'd like, as this will be pretty important throughout this section and also later once you start building bigger and more heavy applications which might require some performance optimization. So we will use this tool throughout this section, and so make sure that you play around again with this a bit more, and then let's move on to the next lecture to talk about our first small optimization trick. Let's now learn about a simple performance optimization technique which leverages the children prop in order to prevent some components from re-rendering. Now, this isn't the most used technique out there, but it gives us actually surprising insights into how React works internally. And so that's why I wanted to share this with you. Also, not many people know about that this is how React works, and so this makes this even more interesting. Now, in this lecture, I want to bring in this test component inside the test.js file, which was part of this project here in the beginning. So this test component implements a very simple counter. So it has a button to increase the count, and it also displays that count. And then the count also contains this slow component. And so what this slow component does is to basically create 100,000 words and place them into an array. And it then renders this 100,000 element long array here in our user interface. And so let's now include that here below our list just to see what's going to happen. So this is basically an experiment with which I will show you that optimization technique that I was talking about. So let's include that. And it's not list, of course, it is test. So let's include the test here inside the list. And then let's see what we get here. And by the way, if your application is taking way too long to load, you can always quit the application and restart it, or you can try to reduce the number of elements right here. So maybe 100,000 is a bit too much for your case. And yeah, so if that doesn't work for you, then just change the number of words there. So you see we have like this infinite amount of words now. And the idea here is that this simulates a very slow component. And so let's see what happens as we click here. So I click, and then it takes like half a second until the button actually updates. So let me do that again. So maybe you can hear my click. Let me do that just one more time. And probably for you, it also takes this long. And so the reason for that is right here. So basically here, each time we click on the button, this state updates. And so this entire component needs to get re-rendered. And so therefore, this slow component is also re-rendered each time that we click the button, even though this actually isn't really dependent on the state. So the slow component does not need the state at all, but still it is being re-rendered simply because it is inside this test component. So if you ever find yourself in a situation like this, where you have one kind of slow component inside another one, which updates this one without it needing it, this is where you can then use this optimization technique. So what I'm going to do is to take the counter functionality out. So counter like this. And let me just copy all of it. But here not the slow component. But instead, here I will now render the children prop, because we will now pass this slow component into the counter as children. So let me comment all of this here out. And let's return a new div here with the same h1, just so it all looks the same. And then here, comes the counter. So just like this, and then this is where we place the slow component. And so this actually looks exactly the same. So the component tree will also be exactly the same, where we see here that basically we still have the H1, the button, and then in the UI, the slow component. So this entire list here. However, it will now work in a completely different way. So let's see what happens now when I click here. And you see that it is instant, right? So this means that actually probably this list here is no longer being re-rendered. And we can actually prove that by clicking here now on the Start Profiling button, then updating the state by clicking on the button, and then stopping it here. So here is of course the counter, so the counter component needed to update, but then we see that the slow component did not render. So why is that, even though basically our JSX is very similar? So the structure of the output is very similar, and indeed it does look exactly the same as it looked like here in the UI previously, right? So the only thing that we changed is that we no longer have slow component here like this, but instead we pass it in as a children. And so then here we display it as a children. So why does this work this way? So why is suddenly React no longer re-rendering this component? Well, again, this element, the slow component, has this time been passed in as a children prop. And so what this means is that this component here was actually already created before the counter component re-rendered. And so therefore, there's no way in which this component could have been affected by the state change in the counter, right? So again, as React sees this piece of JSX here, it will basically immediately create the slow component right here and then pass it into the counter. So all while rendering. And then as we click here on this button, the counter is of course re-rendered, but this component again has already been pressed in as a prop. So it has already been created before, and so it cannot be affected by that state update. It already exists. And so that is the reason why React then bails out of re-rendering this children component, because nothing could have changed inside of the slow component. So React is smart enough like this and can therefore decide not to re-render this. Okay, so hopefully this made sense and that you found it as interesting as I did. So when I first found out about this not too long ago, I was quite surprised that React works this way. And so you might actually find situations like this in the real world in your own code. And so in that case, just be aware that this trick exists. So all you have to do is to refactor your code a little bit so that you can pass the slow component, whatever it is named in your case, as a prop. And it could also be some other prop. So you can call this like show this or whatever, and then you pass the slow component in there like this. So that would work exactly the same, because then also React would already have been created, this component here, before anything ever happens inside the counter. All right, and this is really all I wanted to do with this test component. So let's now get our application back to normal, but this actually has another very interesting implication in the way that our context works right now. So let me again start profiling here and just search once and then stop this. And so here we see again that these two components have not been re-rendered. But why is that? Why have they not been re-rendered? I mean, there has been a state update inside the post provider component, right? So this post provider right here is actually just a regular component. And so when we searched here, we updated this state, which then re-rendered this component. And so therefore, all the child components should have re-rendered as well, right? So all of these should have re-rendered as well if we follow that logic, because again, all of them are child components. However, we see again that these two did not re-render. And the reason for that is exactly the same that we saw earlier with the test and the slow component. So the reason again is that all of these child components here were actually passed into the post provider as children. And so we are in the exact same situation as before, where all these child components were already created before they were passed here into this component. And so then React once again bails out of re-rendering all of them because they couldn't have possibly been affected by any state change, unless, of course, they do actually consume the context itself. So that's the case for this one. Well, now we cannot see that because I reloaded the page in the meantime. So I would need to turn this setting back on, but this only works for the next time. Well, let's just do that now again. All right. So yeah, now we can see that. Let's make this a bit bigger. And so this one here did re-render again because the state has updated. And then this one has changed only because the context has changed, not because the parent component has re-rendered. So the same here and the same here. While again, these ones were not re-rendered because they were passed in as children, and so they were already created before the post provider was even created, and so they could not have been affected by any state change in there. Okay, so I hope that made sense and that you keep this technique in the back of your mind, even though it is probably not used all the time. But it's very, very interesting. And I think this puts you in the top 1% of React developers when it comes to knowing about this kind of stuff. Over the next few lectures, we're gonna add 3 more React tools to your toolbox: the memo function and the use memo and use callback hooks. Now, the fundamental concept behind these 3 tools is memoization. So that's not memorization, but really memoization. So memoization is an optimization technique that executes a pure function one time, so let's say function A, and then it stores the result in memory, so in a cache. Then, if we later try to execute the same function again with the same inputs, it will simply return the result that was previously stored in the cache. So the function will not be executed again. And that makes a lot of sense, right? So if the arguments are exactly the same as before, it means that in a pure function, the output will be the same. Therefore, it makes no sense to execute the entire code again if we can just read the cached result. On the other hand, if the inputs are different, then of course the function will simply be executed again. So that's the concept of memoization. But you might be wondering what this has to do with React. Well, in React, we can use this technique to optimize our applications. So we can use the memo function to memoize components with exactly this principle, and we can use the use memo and use callback hooks to memoize objects and functions. And doing so will help us prevent wasted renders and improve the overall application speed. Okay, so now that we understand what memoization is, in this lecture, it's time to look at how to memoize components using the memo function. So, React contains a memo function, and we can use this function to create a component that will not re-render when its parent re-renders, as long as the past props stay the same between renders. Or, in other words, we use memo to create a memoized component. And if we think about it, this is exactly the optimization technique that I explained in the previous slide. So the function inputs are props, and calling the function multiple times is equivalent to re-rendering in React. And therefore, memoizing a React component means to not re-render it if props stay the same across renders. And just like with memoizing regular functions, this makes a lot of sense, because why re-render the component if the input data hasn't changed at all? Now, the regular behavior in React without using memo is of course that whenever a component re-renders, the child component re-renders as well. On the other hand, if we memoize the child component, it will not re-render as long as the props are the same as in the previous render. Now, of course, if the props do change, then the child component will need to re-render as well in order to reflect this new data that it received. Now, it's super important to keep in mind that memoizing a component really only affects props. This means that a memoized component will still re-render whenever its own state changes, or whenever there is a change in a context that the component is subscribed to. Because in these two situations, the component basically has new data that it needs to show in the UI. And so then it will always re-render, no matter if it's been memoized or not. So, from what we just learned, memo sounds great, right? Now, does that mean that we should go ahead and memo all our components? Well, the answer is no, not at all. So memo is only useful when we're dealing with a heavy component. So a component that creates a visible lag or a delay when it's rendered. Also, in order for memo to actually make sense, the component should render quite frequently, and it should do so with the same props. And let's analyze why that is. So first, if the props are usually different between re-renders, memo has no effect anyway, and then there's absolutely no need to use it. And second, we learned in the first lecture of the section that wasted renders are only a problem when the re-rendering happens too frequently or when the component is slow in rendering. Therefore, if the component only re-renders from time to time, or if the component is lightweight and fast anyway, then memoizing brings no benefit at all. Okay, and now it's time to see this in action in the next lecture. Let's now check out a practical example of memoizing a component. So here we are still in the atomic block project, but for these next few lectures, we actually need the original app.js file from the starter files. So let's move there. So grabbing again app.js, and let's paste it right here in the project folder, and then I'm going to rename it to app-memo, and then let's place it into the source folder. Okay, so let's open that one up here, and then also in index.js, we now need to link that file. So we now want to import the app from app-memo. And we need this component right here, so the original one, because here we don't have any context yet, and instead we are passing some props around, which is what we need for these next few lectures. Now here in the archive, let's actually remove this prop, and let's just add one here called show and set it to true. And then let's come down here to the archive and accept that. So in this lecture, we will actually work with this archive component. Then here, let's make this show archive dependent on this show prop. And then we need to remove this button right here. So this button was using the onAddPost function that we passed in as a prop earlier, but now we no longer have that prop. All right. Now, we never really looked at this component here in the beginning, so let's just quickly understand what it does. So basically, it creates these 10,000 random posts in the very beginning and stores them into the posts state. Now, by default, all these 10,000 posts are not actually shown because we have the show archive state set to false. At least that's what the incoming prop is. Now here, for some reason, it is open. Let's just reload that. And, well, maybe I set it to true up there. Yeah, here I want false, actually. So that by default, that huge list of posts is not rendered. So here we have some conditional rendering based on that state. But as soon as I click here, it will actually open this list of posts. Now let me actually increase the number here a bit to 30,000. But if your computer is maybe a bit slower, then you can leave it or maybe even reduce it. So otherwise, your computer or your browser might crash. So let's see again that when I click on this button here, it actually takes a long time for the entire thing to render. So that's probably like almost a second here. Now the problem is not that it takes a long time to render this list here, because that's just completely unavoidable. So it's so many items that of course it will take some time. Now the problem is that this will slow down the entire page. So watch what happens when I type something here into the search bar. So notice how this created a big lag. So let's show again. So as I type, it takes like half a second until that letter actually appears there. And so let's now also inspect this using the profiler. So let me actually reload again so that the archive is closed. And so then we will do a before and after. So we are now profiling. So now I type and it is really fast. But now let's open the archive. So we have a second render here, or re-render. And then let's type something here. And now it is really slow. But just watch how slow that actually is. So here again, we have the 3 re-renders that happened. And by the size of the bars, we can already see that this last one, so the second letter, was really slow. So here the first keystroke for the H right there was just normal. So everything took like 1 millisecond or 3 milliseconds. So something really, really fast. But then watch how long it took to render the archive. So it took 131 milliseconds. And that's just the rendering itself. So just calling the function. Then painting the whole thing to the DOM took even longer than that. So probably like 1 entire second. But anyway, what matters to us is here this second keystroke. So when I wrote the A there. So notice here how the archive re-rendered when I typed something here. And so the reason for that is of course that the archive is a child component of the app component, which is where that state actually lives. And so if we update the state in the app component, that will then, as we already know, trigger a re-render in all the child components. And so that includes the archive. And notice how it took even so long that all the other components don't even have space to appear here in this flame graph. But if we take a look at the ranked chart, then we see all the other components. And so here again, we can see how fast all of them are in comparison to the archive. All right. And so again, this is the real problem that we have, which is that typing here now makes the entire application really, really slow because it always needs to re-render this really slow component. And so this archive component is a perfect candidate for memoization. So let's do this now here in practice. So the way we do that is to just wrap the entire component function into React's memo function. So we just call memo, which is then imported from React just like useState or useEffect. So notice here that it simply imports memo from React. So it's just another function that comes with React. And then we just wrap everything into that function call. So basically we call memo with the component as an argument, and then this function will return a brand new component. And so then we need to store that component also somewhere. And so we create a variable which we call, again, archive. And so now our archive component is all of this here. So the memoized version of the original archive. And here we could probably even remove the duplicate name and make this an anonymous function, but I guess it's best like this. So just leave the name here as well. And yeah, with this, we have actually successfully memoized the archive component. And remember that this was a great candidate for memoization because the archive component is very heavy, it re-renders very often, and it does so with the same props. So the only prop that it has is this show prop, which is always false. And so, yeah, again, this is a great candidate. And so let's now do exactly the same profiling that we did before in order to show if it improved our situation. So let's start here. So that was fast because the archive is still closed. Let's open that up. And this, of course, takes exactly the same time as before, which makes sense because, as we just learned, memoizing a component has nothing to do with updating state. So memoizing only affects the props. So that list still has to be rendered, and so that still takes time. But what should have changed is the time that it takes to now re-render as we type something else here. So let's try that. And we can immediately see that this was really fast. And now our profiler should prove that. And indeed, now here in the second time that we typed something, it is really fast again. So here, even the first time that there was a keystroke, we can see that the archive did not render. So here it is showing us that this component is memoized even. And so again, it did not render, which is because the prop that it received was still the same as before. So the prop that it received is show, which is always true. And so then this component didn't have to re-render as the parent re-rendered. And again, here the same thing when the component was already opened. And so with this, with the simple memoization, just made our component really fast and snappy again. So we can type all we want, even with that archive open, because it will not re-render on every keystroke. Or also here, each time that we click on this button, for example, which before would also be really slow because clicking here also renders the app component. Great. So this is why and how we memoize a component in React. But now let's do something that will break this memoization so that I can then introduce the next lecture so that we can then solve that problem in the future. So let's say that now, instead of passing in this prop right here, I instead want to pass in an object. So let's create an object here called archive options. And then let's say show is false. And the title, let's say post archive in addition to main posts. And now here, instead of the show prop, I'm going to pass in that object. So archive options, set it to archive options. And now let's get that here. And now here we use archive options dot show, and here we use archive options dot title. Give it a save, then let's reload here, and then let's run exactly the same experiment as before. So just typing something here, then opening here the archive, which as always takes some time. And now as I type, notice how it will be back to taking a long time. So you saw that? And indeed, we are now back to basically re-rendering this component, even though it is memoized, and even though it looks as though our prop hasn't changed. So the archive options that we received still looks the same as before. It's just this object right here. But still, now our archive component was re-rendered again. So let's now find out why this is and how we can fix that in the next lecture. In the last lecture, we found a situation where the memo function didn't actually work as expected. And so let's now understand why that happens and learn about the solution. And let's start from what we already know. So we know that in React, whenever a component instance re-renders, everything in there is recreated. So all values are always created again, and that includes objects and functions that are defined within the component. So a new render gets new functions and new objects, even if they are the exact same ones as before. We also know that in JavaScript, two objects or functions that look the same, so that are exactly the same code, are actually different, unique objects. And the classic example here is that an empty object is different from another empty object. Now, from these two pieces of information, we can understand that if we pass a function or an object to a child component as a prop, that child component will always see them as new props whenever there is a re-render. And if props are different between re-renders, then memo will simply not work. So it will not do its job. So in summary, if we memoize a component, but then give it objects or functions as props, the component will always re-render anyway, because it will always see these props as new props, even when they actually look exactly the same. Okay, but there must be some kind of solution, right? Well, of course there is. So we can make objects and functions stable. So we can actually preserve them between renders by memoizing them as well. And to do that, React gives us two more hooks: useMemo and useCallback. So we can use useMemo to memoize any value that we want to preserve between renders, and useCallback to memoize functions between renders. And I will just use the word values for everything here, because useCallback is actually just a special case of useMemo. But anyway, what does memoization of values actually look like? Well, the idea is similar to the memoization that we just talked about before. So whatever value that we pass into useMemo or useCallback will basically be stored in memory. And that cached value will then be returned in future re-renders. So it will be preserved across renders as long as the inputs stay the same. Now, in the case of useMemo and useCallback, these inputs that I just mentioned are called dependencies. So just like the useEffect hook, useMemo and useCallback also have a dependency array. And this is how it works. Whenever one of the dependencies change, the value will no longer be returned from the cache, but will instead be recreated. So this is very similar to the memo function, where a component gets recreated whenever the props change. It's just a different thing that we're memoizing here, and a different way of specifying the inputs. But the idea is the same. And this will all become quite clear once we start writing the code. But for now, let's visualize what we just learned. So, the regular behavior in React when we do not memoize a certain value is, of course, that a new value is created whenever the component re-renders. On the other hand, when we do memoize the value, then no new value is created on re-render and the cached value is returned instead. And so, like this, the value will stay exactly the same. So it will be stable across renders. However, this is only true if the dependencies that we specify in the dependency array don't change. If they do change, then a new value is actually created as if the memoization has never happened. Okay, now this all sounds great, but when do we actually need this? Well, remember that we started this lecture by saying that we need to make objects or functions stable in order to actually make the memo function work. In other words, if props are objects or functions, we need to memoize these props in order to prevent wasted renders. So that's what the very first slide of the lecture was all about, right? And this use case is probably the biggest use case for useMemo and useCallback, and it made it very easy to understand why there is a need for these hooks. However, there are actually two additional use cases. So the second use case is to avoid expensive recalculations on every render. For example, you might have a derived state that is calculated from an array of 100,000 items. Now, if your component re-renders all the time, then React needs to do this expensive calculation over and over again each time there is a render. And so, to fix this, you can simply preserve the result of that calculation across renders using useMemo. And so then, React doesn't have to calculate the same thing time and time again. Finally, another use case is memoizing values that are used in the dependency array of other hooks, for example, in order to avoid infinite useEffect loops. Now, just like with the memo function, it's important to not overuse these hooks. So you should probably only use them for one of these three use cases and not start memoizing every single object and function everywhere. But anyway, with all this being said, it's time to finally try this out with code. Let's now use the useMemo hook to fix that problem that we created ourselves with the archive component earlier. So remember how earlier we created this object right here and then passed that as a prop into the archive component. Now the problem with this is that doing so actually breaks the memoization that we created for the archive component. So we saw that here in the profiler also earlier, where we saw that after the archive is open, then it again takes a long time for us to see the results of typing here. So we can also see that in action because the application is really laggy and unresponsive as we type into this field. So as we just learned in the previous lecture, the reason for that is that this object right here is recreated over and over again each time that the app component re-renders. And so basically then the prop that the archive receives will always be different. And so then of course memo doesn't do anything. So what we need to do is to make this object here stable over time. And so that's where the useMemo hook comes into play. So let's use that hook here. So useMemo, which again needs to be imported from React. So let's call that. But now it is actually not as simple as just wrapping this entire object into useMemo. So that's not how it works. Instead, useMemo actually takes in a callback function which will be called on the initial render. So very similar to the useState hook. So in this case, all we need is an arrow function which we want to return our object. So return this object right here. All right. So this callback function here is basically the work that should be performed on the initial render and which result should be then stored in the cache. So should be stored in memory so that React can remember it across re-renders. Now in this case, all we're doing is to return an object here, but there could be also some more intensive calculation going on, which is the reason why useMemo takes in a function and not just a value. All right, so again, whatever we return from this function will be saved in the cache. And so then remember, we also need to pass in the dependency array, which will basically determine when this whole calculation here is executed again. So just like the use effect took, right? So by specifying an empty dependency array here, that means that this value will only be computed once in the beginning and will then never change. So it will never be recomputed. And so this should actually already have fixed it. So let's re-render here, clear that. And now our archive is closed. And of course, we want to profile this again. So this is fast as always. Then we just open this again, which takes its time. And now we will see if that memoing has worked. And it was really fast, so it looks like it did. And indeed, the archive was not rendered in the beginning, and also not as it was already opened. Great. So we fixed the problem, and our memoized component is now back to working. So we have now this stable value here over time, which will simply be taken from the cache as long as the dependencies don't change. And speaking of the dependencies again, right now we don't have any, but actually let's create some. Or at least one. So here I now want to change the title to use a stateful variable. So to use the posts. So now here I want to say post archive in addition to, and then the number of the main posts. So that is posts dot length. So it's not the filtered posts. So it's not this value right here, but really the amount of posts that exist. And so now we need to specify that value here in the dependency array, because otherwise this object here will never be recomputed. And so let me first show you that actually this is how it works. So right now it says here, in addition to 30 main posts. So let's add another one and watch what happens. So here it now says that 31 posts were found, but down here we still say 30. And so that's because React is still reading this object from the cache, which it didn't update, because we didn't place this post variable into the dependency array. And so therefore, this function here was never called again. And so then React is still using the stale value of this post state. So here we are again in the presence of stale state and of a stale closure. So a stale closure because this function here was created initially, and from there on, it now remembers all the variables that are referenced inside of it as they were at the time that the function was created. So that's what a closure is, and it is a stale closure because it never run again. And so it is still remembering the old values. So that's one of the weird things about React, which is very confusing for beginners. But that's why I'm talking about this time and time again, because this is the kind of stuff that you really need in order to master React. But anyway, let's now then place the entire thing here into the dependency array. So not just posts, but really posts.length, which is a lot better because post is an object and this is a primitive. So it's always best to have primitives in the dependency array. And we will learn more about that even later in this section. But anyway, you can see that it actually already updated there to 31. But let's change this again, or test this again. So 31 up there, and beautiful. Now it updated down here as well. Now the consequence of this is that whenever this archive is open, it will then take a long time to re-render the application when we add a new post. Right? So let's check that. And now I will just call something very short so that we don't get all those re-renders in the profiler. And then notice how that took some time. And so indeed, we can see that here in this last state update, where now the archive, of course, still had to re-render, because now, this time, our object here actually has been recreated. So we added a new post, and therefore posts.length was changed. And so then this object here became a new object, making it so that the prop changed, which in turn triggered the archive to be re-rendered as a result, even though it is memoized. Okay, so hopefully all of this made sense. And later on, we will actually see another use case of the use memo hook. But for now, let's move on to the use callback hook. After use memo, now it's time to quickly also use callback. And as we already know, the goal of the use callback hook is to memoize functions. And so to test this, let's now pass in a function again into the archive component. So let's now bring back the onAdd post prop that we had here initially, but that we removed. So onAdd post should be handle add post like this. And then let's grab this prop and receive that here in our memoized archive component. And then we can reactivate this button right here. And so then if we reload this, and here let's clear. So now we get this button here that we can click, and that will then, as you see here, add it to this list. And so now we have 31 posts, and if we add another one, then we have 32, and so on. So that's the goal of that function. Now the problem with that is that now we are back to having the same issue as before. So let's again, well, first let's close this actually, so that we have the before and after. And actually let's this time test with this button here. So this fake dark mode button also changes state on the app component. And so it will also re-render the archive. So let's click that. Then let's open the list. And then let's set the state again. And so maybe you saw that it took a long time. And yeah, so we are back again to having our memoized component re-render, even though it is memoized. So we had the same problem earlier in the previous lecture because of this prop here, which is an object, but we solved that by memoizing it using useMemo. And so now we have the same problem, but with a function. So now this function here is causing us the same problem, and the solution is the same. So the solution is also to now memoize this function. And so let's do that by using the use callback hook. Make sure that it gets imported from React. And then here again, the dependency array, which is empty. And so this will then return the memoized function, which we can then store into a regular const variable. Okay, and that's actually it. So you see that useMemo and useCallback are pretty similar, but the difference is that useCallback will not immediately call this function, but will instead simply memoize this function, while here useMemo will basically simply memoize the result of calling this callback. So that's the main difference. useMemo just stores a result, so like a value, which is the result of this callback, while here in useCallback, only the function itself is actually memoized. All right, and so this should already be enough to solve our problem. So let's clear that. Let's do exactly the same thing again. So this was fast. And let's see. And this also seemed pretty fast. And our profiler confirms that result. So we are back to not re-rendering the archive component. So memoization is back to working indeed. And we also noticed a very noticeable difference in the speed and snappiness of our application. Now, some teams, for some reason, choose to wrap each and every function and value into a useCallback or a useMemo. But that actually makes very little sense, and it might even do more harm than good in most of these cases. So using one of these functions here, like useCallback, actually has a cost as well. So React needs to run this function and needs to store the function in memory. And so that only makes sense if we actually see some improvement here in our application. For example, this component right here, there's no need to wrap it into a useCallback because this is not creating any problems for us anywhere in the application. And so it's best to just find some slow components that do actually have a visible bad performance and then using the tools that we just learned about to only optimize those. Okay, but we already talked about that before when I first introduced these two hooks, where I showed you the three big use cases of these two hooks. Now, one thing that I wanted to mention, which I didn't mention in that lecture, is that in the future, the need to doing any of this stuff, like any of the memoization, might actually disappear completely, because the React team is currently researching a compiler that would basically automatically memoize all the values that need memoization behind the scenes. But still, even with that on the horizon, it is still very good to know about all of this stuff. First, because that compiler might actually never happen, and second, because you will still see these hooks here all the time in a bit older code bases. So you should definitely know about how this works, and of course also know how to use the profiler to find some low performing components, and also all the other techniques that we're going to talk about throughout this section. And finally, I want to just quickly finish with a small experiment. So let's pass in another function into our archive component, but this time a special one. So let's say here this setIsDark function. And I say special because this is the function that is returned from useState. And so let's pass that as a prop just to see what happens. Already passed that. So set is fake dark. And just like this. So we are again now passing a callback function here as a prop, which we did not memoize. So let's see if that will then again slow down our component. So let's record. Let's do it once. So the fast version. And again. But it did seem pretty fast. Maybe you noticed that as well. And we see that actually the archive did not re-render. So the memoization is indeed still working. So even though we did not memoize, set is fake dark. So why do you think that is? Well, basically React guarantees that the setter functions of the useState hook always have a stable identity, which means that they will not change on renders. So we can basically think of these state setter functions as being automatically memoized. And in fact, this is also the reason why it's completely okay to omit them from the dependency arrays of all these hooks. So from useEffect, useCallback, and useMemo. So in fact, we do have a state setter function right here. So we're using a function here inside this use callback, but still React or ESLint is not complaining that we're not using that function here in the dependency array. While if we were, for example, to use, for example, just the posts, then here React would complain. So here we would then have to place the posts inside the dependency array so that whenever the posts change, React could then update the function here in the cache. So could basically cache the new version of this function with these new variables. But again, with the state setter functions, that's not necessary. And that's true for all the dependency arrays in all the 3 hooks that have them. Now, okay, now that's actually all I had to tell you about these 3 important tools. So memo, use memo, and use callback. Now, as I mentioned earlier, you're not going to use these tools all the time when you work with your own React applications, but you still need to have them in your toolbox. And I know that they are really quite confusing in the beginning. So it took me actually a long time to understand when I should use each of them. But that's why I tried to give you these demonstrations, to show you the use cases in the theory lecture, and then all you can do now is to really practice these functions, maybe in your own examples, or in the future in your own applications as well as the need arises. Okay, and actually next up we will use some of these tools a bit more to optimize context.